Hello, everybody. It's Mrs. Pound, and we are starting a new chapter, chapter 4.2 on work and energy. So, the first thing we need to do is we need to define work and energy, and that is done in section 421. So, our objectives for today's video are to correlate the terms force, motion, work, and energy, to calculate the amount of work done when given force and distance, and distinguish between potential and kinetic energy. So, work. We all do a lot of work all day. You do hard work in school. I bet you worked really hard on an English essay recently here. But when we talk about work, a lot of times the definition that we use in regular everyday life is not the same as our definition in physics. So when I talk about doing work in physics, it's the measure of the energy transferred when a force is applied to an object that causes it to move, and at least part of that force is in the direction of the movement. So, in order to do work in physics, you have to move an object. Okay, so this little boy in the background, he is moving this dolly, and so he is doing work. But if something was placed on the dolly that was too um, heavy for him to move, he could not push it, he would do no work. No matter how much he strained and how much he sweated and everything else, no work would be done. It has to move. And I also want to emphasize the force and motion must be in the same direction to do work. Okay. If they're in different directions, no work is done. For instance, if he were to pick something up off the ground, he's moved it a distance and he's working against the force of gravity and he has applied force to lift it up. He has done work. But if he then walks with the basket, he does no work because the force is up and his motion is to the left or the right. So he does no work in that case. The formula for work is force times distance, written as W equals F times D. So the units are a Newton meter, which can be combined to make a joule. So the unit for work is a joule with a capital J. So a question you might be asked is how much work is done when lifting a 6 kilogram bucket 2 meters? Well, we're going to use our equation, work equals force times distance. And we notice that we have the number 6 kilograms, which is mass, and 2 meters, which is distance. But my equation calls for force, not for mass. But we know how to get the force. Do you remember that you just multiply the mass times 9.8 meters per second squared, the acceleration due to gravity? That's the equation F equals m times a. Okay, so we can substitute that in there times 2 meters for our distance. When we multiply that together, we get 58.8 newtons, because a kilogram times a meter per second squared is a newton, times 2 meters. And we end up with 117.6 newton meters, or 117.6 joules. Now, related to work is energy, because this is the ability to do work. And I just want to remind you that all energy here on Earth comes from the sun. That's why I have solar panels here. Its unit is the joule because work is done with energy. They use the same units, they are interchangeable. If you know how much work is done to do something, you know how much energy was required to do it. Now, there are two states of energy. The first state is kinetic energy. This is the energy contained in moving objects. So, if an object is moving like this person on the bicycle, then the state of the energy is kinetic, it is in motion. There is also potential energy. This is the other state. This is the energy that is stored by way of an object's position, chemical makeup, or elasticity. So, by position, I mean If an object is higher up, let's say if we have a shelf and one object is on the lowest level on the lowest shelf, another object is on a higher shelf. The one with more potential energy is on the higher shelf because you know if they were to drop and say fall on your foot, okay, the one that's higher would hurt more. And it also required more energy initially to lift it up to that shelf. Also, chemical makeup, batteries store energy that we use. Food stores energy, potential energy, and elasticity. This is talking about like a slingshot it has like a rubber band type thing on it. You pull it, okay, rubber bands, elastic potential energy. So you pull it back, it has stored energy, you let it go, and then that becomes kinetic energy. So there's also you can convert from potential to kinetic energy, these two states. It's kind of like matter, where you can convert between the different states of matter. You can convert between kinetic and potential energy as well. So, our objectives were to correlate the terms force, motion, work, and energy, to calculate the amount of work done when given force and distance, and distinguish between potential and kinetic energy. So, 5 questions, and I will be back with more about uh, force or work and energy.